If we want to go really extreme, there's this bash test. And bash test is using another device which basically implements a bash shell for us. The bash device, not too bad to interact with basically. Bit 0 is reserved, bit 1 says I want to send something to the shell, and after it's been received that bit will be cleared. Bit 2 says let me know if you have something for me to read, and it will be cleared after that's been processed. And if bit 3 is set at that point, it means there's data available, I can read it from the data register. Bit 4 I can turn on to make all of this interrupt driven, and any time that the shell sends me a character it will fire an interrupt. Bit 5 I can turn on to say are you alive, and when that's cleared I can check bit 6 to see if the shell is still alive or not. Let me close off my telnet session here, and let me reset the pig over here. So that's the bash shell, and it's probably the most complex device I've got. It uses 2 children to implement the bash piece of this, and there's all sorts of stuff that goes on in there. So let's take a look at this bash test.mac. Pretty short program. Using interrupts, so we set up an interrupt handler. Talk to the PigBus controller, enable interrupts, and then put device 6, that's the bash shell, into slot 80 for no particular reason. Enable interrupts in the bash shell, and then our main loop basically read from the console, display the character that was typed on the LEDs just for fun, see if switch 1 is up. Let me reset this, and if switch 1 is up I'm going to do a local echo, so I'll take the character that you just typed and I'll call character to console, and then I'll send it to bash, and that's my whole main program. Read a character, optionally echo it, send it to the bash shell, and this is all support code. String to bash just goes through a string and calls character to bash one by one. Character to bash moves a character into the data register, turns on the request to send bit, waits till it's cleared, and then returns. Reading a character from bash turns on the request to read, waits until that is clear, and then looks to see if data is available. And if it's not, I go back and try this again. So this is a blocking read from bash. I'm only going to call this after I get an interrupt request. So that's read character. This was just test code that I left in here. Console I/O, we just talked to the console through 177, 564, and 560. We've done this in another video. And the interrupt handler basically just calls read character and displays the character on the console. A bit of test code here in our constants, and that's all we've got. So we can assemble that, and then load A and continue, and we're talking to the console, which by default is just right here. So I can say PWD and hit a Control J, and it shows me my working directory. I can say ls and hit a Control J, and it does an ls on my current directory. And this is totally raw, right? So character 10 is a line feed, it's not a carriage return line feed. So I can turn on a local echo, and I can say, date, and Control J, and there's the date. And uptime, and Control J, and there's the uptime. And if I try to hit and enter, nothing happens. When I hit Control J, it says PWD followed by carriage return, command not found. So got a whole bash shell that I'm running from less than 100 lines of macro code. And again, we're leaning heavily on the underlying machinery of the simulator to be able to make this happen. If I do my dev command over here, I can see I've got 2 bash processes running. One is a parent, one is a child. That's used to send and receive commands and so on and so forth. So that's that's the more complex device, the bash shell. But again, pretty straightforward example.